Okay, this is section 12.2. We're going to talk about something called the ellipse today, but before we do that, I want to do a quick review about seeing if you remember how to find the equations for circles. Yes, circles. So let's take a look at these, okay? First one here, A. Hopefully you see the center is at 0, 0, and hopefully you see the radius is 3, so hopefully you've written down x squared plus y squared equals to 3 squared, which is 9. How about part B? Yes, it seems like the center got shifted to the right, so x minus 2 all squared plus y squared equals to 9. C seems to have the center shifted to the left, 3, 0, so x plus 3 all squared plus y squared equals to 9. D looks like it got shifted upwards to 0, 2, so x squared plus y minus 2, hopefully you remember from last time. Remember, opposite, shifting up, y minus. The radius is still 3. E, x squared plus y squared equals 2. I think this time the radius has changed. It's now 4, so 16. F, notice that I think the center got shifted, so x minus 2 all squared, y plus 3 all squared equals to 16. Oh, we got the I for G. See, the eyeball. Okay, sorry. Let's go back. Let's just do math. Can we figure out the equation of the inner, I guess, circle here? Yeah, that's a circle with radius 1, so that's cool. What about that weird shape, the elongated shape that looks like a football? What do you think we did to it? What do you think we did to the circle in order to make it elongated or expanded? Ooh, did I use the word expanded? Yes, I did. Do you see how there's a horizontal expansion by a factor of 3? It used to be 1, right? The radius, but now it's like 3 going horizontally. What about the vertical? It used to be 1, but now it's doubled. It's 2, so it's a vertical expansion by a factor of 2. How do we deal with expansions and compressions in Unit 1 when we did transformations? Hopefully you remember that instead of having x, we now have 1/3 of an x. And then a vertical expansion, yes, we always multiply the function by 2, but if you moved it to the side, do you remember this from chapter 1? If you moved it back to the other side, so it becomes y over 2. So once again, vertical expansion by a factor of 2. So notice how we can rewrite this as 1/2 y then all squared equals to 1. Or better yet, just x over 3 all squared plus y over 2 squared equals to 1. And that is the equation of that weird elongated shape, which, by the way, has a name. It's called the ellipse. So the rest of these H, I, J, K, L are ellipses. So can you see what happens? It's really just an expansion horizontally. In this case, the radius of 1 became now 1, 2, 3, 4, 5. So x over 5 all squared. Vertically, it went up to 4. So y over 4 all squared equals to 1. Done. Can you try I and J, please, yourself? I'm going to ask you to pause the video now and then come back and check your answers with mine. Press pause. Okay, glad you're back now. Did you get x over 2 all squared? Y over 4 all squared equals to 1? I sincerely hope so. For J, did you get x over 2 all squared? Y over, was it 1, 2, 3, 4, 5, 6? Equals to 1. And then for K, did you notice, I didn't ask you to do those, but if you did, because you're just trying to get ahead, did you notice how the center also got shifted? So not only is it an expansion, but there's also a translation, so x plus 2 all over 4 now is what you should have written down. The y values don't shift up or down, but the expansion of a factor of 3 did occur. And finally, now you try L. center is negative 3 over 1. Oops, it's not 1, this is 2. Getting too excited. 1, 2, 3. Don't forget the square. And it always equals to 1. Great. So, in general then, the graph of x over a all squared plus y over b all squared equals 1 is an ellipse, which of course can be obtained by expanding or contracting the circle using horizontal expansions or vertical expansions compressions. So if I asked you to do this, see once again the I, right, the center of the circle, and then it became out here. And if I said the a value was the expansion factor, that means this distance here must be a, or the coordinates of this endpoint here is a comma 0, and the coordinates of this endpoint is negative a comma 0. Similarly, if the expansion in the vertical is b, then this y-intercept here is 0 comma b and 0 negative b. So knowing this, can you tell me what the domain would be? If you said the x value has to be between negative a and a, you are correct. And if you said the range had to be between negative b and b, you are also correct. And if you said the center is 0, 0, definitely this only works, the domain and range, it only works if this answer only works when the center is 0, 0. And you can clearly tell that the x-intercepts are just a comma 0 and negative a comma 0. The y-intercepts are 0 comma b and 0 comma negative b. Okay? Now if you're curious about what the formal definition of this weird shape is, the ellipse, it's really this. An ellipse is the set of all points x, y in a plane, that's just in a two-dimensional plane, such that the sum of their distances from two fixed points, and these fixed points are called foci, is a constant. So it says each fixed point is called a focus, and of course foci is the plural. Meaning, if I were to take this distance in red plus this distance in red, and if I were to take any other point on this ellipse, let's say over here, this distance in blue plus this distance in blue, those sums will be the same. So the sum of the distances of the two blue lines, or the sum of the distance of the red lines there, are always going to be the same no matter where I am on this ellipse. So if you want to draw one nicely, then you can just use a piece of cardboard, two thumbtacks to represent your foci, and a pencil and a string. You put the thumbtacks on the foci. You cut a piece of string that's longer than the distance between the two thumbtacks. So you have to be longer than this distance here. And then you just pull it tight and draw or trace. And then you'll get a nice ellipse. Now note the ellipses can be elongated in either the vertical or the horizontal direction. So we have special names for things. The longest chord in the ellipse happens to be called the major axis. And the shortest one then, of course, is called the, whoops, what did I just do? Undo, please. Undo. It's called the minor axis. You're thinking chords, major, minor? We're talking about music theory here? No, we're talking about ellipses. I'm so sorry. Now the major axis and the minor axis always intersect. They intersect at the center of the ellipse. And the endpoints of the major axis are actually called the vertex, or vertices of the ellipse. Now there are two different samples of ellipses here. When A is greater than B, that's the one on the right. Notice that this value here is A, and this one here is B. We have here the length of the major axis would just be double of A, so that would be this distance. That's the major axis. And the minor axis would be the other one, 2B. Notice, of course, when B is greater than A, we switched it around. The major axis becomes the vertical, so that's 2B. And the minor one then becomes the horizontal, 2A. Okay. So, let's try some examples now. Can you start with this graph, and can you sketch it out? And then sketch out one that's got transformed. Hopefully you can see that x over 16 is really written as x over 4 all squared. Now you can see that there's a horizontal expansion by a factor of 4. And then the y squared over 25 can be written as y over 5 all squared, a vertical expansion by a factor of 5. And thus you should be able to draw it out. 4 each way horizontally, 5 up and down, Ta-da! There's my ellipse. And the other one over here, the only difference is you have it shifted 2 to the right, I think. And then 3, yes, down. So do that as well. Shift the center 2 to the right, 3 down, and then go 4 horizontally, and then 5 vertically. Connect, and there you go. Now you should be able to figure out the length of the major axis. In this case it's vertical because that's the longer one. 2 times 5, which is 10. The minor one in this particular example is the horizontal. 2 times 4 is 8. The center is 2, negative 3. And then the vertices, because they are on the major axis, that would be this point here, which is 2 comma negative 8. And also the other one, 2 comma 2 up here. So in general, the standard form of an ellipse, where the center is at h and k, is x minus h all over a all squared, plus y minus k all over b all squared equals to 1. And just to double check once again, depending on what, if a is bigger than b, we have different types of ellipses. In this case here, on the left, the a value is this. So there's a, here's b. Major axis, of course, in this case is horizontal to a. Over here though, look, b is much bigger than a, so the major axis is your 2b. Okay. Okay. Alright, next page. See if you can do number 2 yourself. Okay, I want you to find the standard form of this conic, so I'm going to let you at it, and then once again I'm going to ask you to press pause, then come back when you're done to check your answer. Remember, the major is always the longer one. In this case, the vertical one looks like it's 8. So remember, the value of b is just always 2. Double of b gives you the major axis length, so b must be 4. Minor axis in this case is the horizontal 4, so that must be 2. So the equation in standard form. Did you get this? Please say yes. So therefore, you and I are happy. Good. All right, how about example number 3? This time I'm asking you to sketch the graph, but it's not in that nice standard form. The standard form always has a 1 on the right-hand side. So in order for me to do that, I need to, you guessed it, divide every single term by 36. And if you do that, 36 over 36, of course, equals to 1. And the x squared over 36 can be written in bracket form as x over 6 all squared. The 9 in the 36 simplifies to 1/4, so this just becomes y over 2 all squared. And now you're all set, because you know this is an ellipse centered at 0, 0. One that is expanded horizontally 6 units, and then expanded vertically by 2. Nice flat football or ellipse. Okay. I'm going to let you try example number 4 yourself, and then, like I said, when you're done, come back and check your answer with mine. If you're not too sure what this word tangent means, that just means it touches. So x equals to -5, x equals to 1. If the center, is on the line y equals 3, interesting. So the center's here. Hey, do you know what the center could be then? Since it just touches, that means this must be the end point, so the center must be halfway in between. Bam, bam, bam. The center, I know, then must be -2, 3. Nice. And it says the length of the major axis is 12, so I'm looking here and I'm thinking this distance is 3, this distance is 3, so that axis must be the minor one. because the minor axis seems to be on the horizontal since the value is 6 and not 12, which also means that if I were to solve for a, I get a equals to 3. And knowing then by deduction that the major axis must be the vertical, that means 2b equals to 12, so b equals to 6. Perfect. Let's go 6 units. 1, 2, 3, 4, 5, 6. Stop. 1, 2, 3, 4, 5, 6. Stop. Whee! Ta-da! Ooh, that didn't look so good. You get the idea. And then we can find the equation then. X plus 2 all over 3 all squared plus y minus 3 all over 6 all squared equals to 1. Done. Alright, one last page. Here we go. Oh, can you write this in general form for me? Just like how we did that for the circle last day, we can do the same thing for the equation of the ellipse. In this case, we need to clear the fractions or get rid of it. I would multiply, of course, by the lowest common denominator. That would be 36. So here we go, 36 x plus 2 squared over 9. 36 y minus 3 squared over 36. 36 times 1 is 36. Remember, multiply every single term by 36. We can simplify the 36 to 9. That becomes 4. 4x plus 2 squared. Y minus 3 squared equals to 36. And then we are asked to expand the brackets, so I'll quickly do that. Some lovely expansions from, I don't know, when did we learn that stuff? Grade 9, grade 10? I forget now. And then don't forget to expand out the factors. And then finally, I would like you to collect the like terms or the constants on the left side. I'm going to organize this by putting the x squared terms first, then the y squared terms, then the linear terms of 16x minus 6y. And then we have here 16, 9, and 36. 16 and 9 is 25. 25 minus 36, I believe that's negative 11. And then don't forget, equal to 0. So this is our general form. And just like the circle, we have it where it's ax squared plus cy squared plus dx plus ey. And once again, the constant and the right-hand side always equaling 0. So that's the general form of the equation, the equation of the ellipse. And it also actually could be the equation of the circle, especially when a equals to c. So that's just a special case. You can say that the circle is just a special case of the ellipse, where both the major axis and the minor axis are the same length. We just call that the diameter in a circle. Okay? So finally, number 6 now. Can you graph out this conic? So the idea is you got to change this into standard form, then graph it out. Just like last time, how do we change it into standard form? We had to, oh yes, complete the square. So I'd like you to do that here as well, and then we should be able to graph it out. So when I ask you to do these questions, my advice is to take the constant term and move it to the right-hand side. I would also suggest that you group all the x's together and then all the y's together. Just easier to see. Hopefully you can see that there's a common factor of 25 amongst all the x terms. A common factor of 16 amongst the y terms. And then hopefully this makes it easier for us to find that magic number. Half of 4 is 2, 2 squared is 4, so plus 4. Half negative 2 is negative 1, squared is plus 1. And then, of course, we have to balance it out, so we have to add 4 and add 1. Correct? Not correct. Don't make that fatal mistake. We didn't really add in 4, we added in 25 groups of 4. Ay, ay, ay. By the way, we didn't add in 1, we added in 16 groups of 1. And so now 25 times 4 is 100, plus 1600 is 16, plus 284. Yes, I am a human calculator. No, not really, but it's 400. I can rewrite these as squares then. X plus 2 all squared. 16 is y minus 1 all squared. And then once again, we need to divide both sides by 400 because I want this to be equal to 1. 25x plus 2 squared over 400. 16y minus 1 squared over 400. And then we should be able to simplify these terms. I think that just becomes 16. And then I think that just becomes 25. And you'd be thinking, oh, these are nice numbers, so that means I did it right. All these math people and math teachers, they always want to have nice numbers, don't they? And so you're in luck this time. Here are your nice numbers, and here's the correct answer. And then finally, can you graph it out? I'm going to say yes, you can, but I'll just do it quickly for you anyways. -2 comma 1, go 4 to the right, 4 to the left, 5 up, 5 down, connect them. Ooh, didn't draw it really nice, but connect them together, and then you are